Hello everybody, welcome to the last unit of Chem 20. It's called stoichiometry, and we're going to begin it off with a unit called, the lesson called Net Ionic Equations. Now the goal of this lesson is to predict products of the reaction, write a total ionic and net ionic equation. So we're going to be doing some review of Science 10. We want to be able to write and predict products of a reaction. And then we're going to learn something new, how to write total ionic and net ionic equations. For today's review, we are going to write an example of each type of reaction. There are 5 types of reactions that are good to know about, and they will be very helpful in this unit. The first type of reaction is called formation. Formation, think about something forming. Okay, so what's going to happen in a formation reaction is you're going to have 2 or more elements or come together to make one species. So I'm going to be writing balanced reactions. 2 magnesiums react with oxygen gas to produce 2 magnesium oxide solids. Now notice, whenever you are writing a reaction, you want it to be balanced. Whenever you are writing a reaction, you need to have states, an arrow, plus arrows, because it tells us what state it is, etc. Okay? If something is in solution, then you need to check whether it is aqueous or not. Okay, let's go into decomposition. Let's do a simple one. Take water. We know that water is in liquid form. And it breaks down to form hydrogen gas and oxygen gas. This is pretty cool, electrolysis of water, and then you can collect the hydrogen gas and do a pop test on it with some flame. The next one is called single replacement. There are two main types of single replacement. Some students like to see them 2 different ways. Others just go with what is there. So first type of single replacement reaction I'm going to say, we have magnesium chloride reacting with bromine gas. When you are looking at a single replacement reaction, you're going to look at what do you have in the elemental form. So in this case, I have bromine, and bromine should be a liquid. I have bromine that's by itself. It's going to switch places with either the magnesium or the chloride. You're going to ask yourself, is bromine a nonmetal or a metal? It is a nonmetal, so it makes sense for it to switch places with the nonmetal. Okay, so it's going to produce magnesium bromide plus chlorine gas. So notice how those 2 switched places. Let's take a look at another example. Now we have NaCl. And we're going to react it with beryllium. You're going to ask yourself, beryllium, it's by itself. Is it a metal or a non-metal? Well, beryllium is a metal, so it makes sense that it switches places with the metal. So going forward, we're going to have beryllium chloride and plus sodium solid. Okay, last thing we're going to do is make sure it's balanced. You're going to end up with a 2 here and a 2 here. Double replacement. Now, double replacement, we are going to have two compounds reacting with each other. So let's say we have, I'll do it in different colors. The first compound is barium hydroxide, and that's a solid, reacting with, do pink, potassium iodide. Now, you need to pick. You're either going to switch the metals or you're going to switch you're either going to switch the cations or the anions. It doesn't matter as long as you're consistent. So for this, I'm going to switch the metals. We're going to end up with potassium hydroxide. Sorry, that should be aqueous. And we are going to have barium iodide. The last type of reaction that we have is combustion reaction. This takes a hydrocarbon, so something that is made up of only carbons and hydrogen, for example, methane, and it reacts with oxygen. When the wording says something like a hydrocarbon reacts, so let's say methane reacts with oxygen, that indicates that it's a combustion reaction. Or methane is burned. Burned means that it was reacted with oxygen. Or methane combusted. Those are all different ways of wording a word problem to say that this is undergoing a combustion reaction. So you're going to react that with oxygen gas. Now, the products are always going to be carbon dioxide and water vapor. So H2O gas, not H2O liquid. There is no such thing of liquid water coming out of a fire. And then the last thing we're going to do is balance this. So we're going to have 2 oxygens and 2 waters. Great. If you are having troubles balancing, I believe I do have a video earlier on with Science 10 review. Watch that and that'll help you with balancing. Okay, net ionic equations. A net ionic equation is a chemical reaction that only includes reacting entities. So let's take a look at an example of how to form a net ionic equation. Step 1 is to write a balanced reaction. So we have zinc reacting with copper. This should say copper 2 sulfate. Zinc is a metal, and it is reacting with copper 2 sulfate, which is CuSO4. And we're going to assume that these reactions are usually happening in solution. So it's going to be aqueous, okay? And I've checked on page 6 of my data book to make sure that, yes, this is aqueous. From here, you're going to determine what type of reaction is happening. Well, I have a metal reacting with a compound. That looks like a single replacement. By itself, I have zinc. That's a metal. That means it's going to switch places with another metal, which is my copper. Then, so we end up with zinc sulfate, aqueous, plus copper metal. Step 2 is to write a total ionic equation. Basically, what we're going to do is take all of our aqueous compounds and write them as ions. This can only happen to our aqueous compounds, not solid, not liquid, and not gas. So anything that you see in solid, liquid, and gas, they are going to remain solid, liquid, and gas in our total ionic equation. So zinc, that's a solid, it's going to remain. The next compound we have is copper 2 sulfate, and it is aqueous, so I'm going to split it into its ions. Copper 2 means that it has a charge of 2, Cu aqueous 2 plus. Sulfate, there is one sulfate and it has a charge of negative 2, and it is also aqueous. Producing on this side, we have zinc sulfate. Zinc has a charge of 2 plus, and it's also aqueous. And then sulfate has a charge of negative 2. And then copper is going to remain as copper because it is solid. From there, we can write a net ionic equation. And we do that by canceling out our spectator ions. In this example, our spectator ion is sulfate. Does anybody know why sulfate would be our spectator ions? The reason is it because it appears on both sides of the reaction. So just like in math, let's say we have something x is equal, or sorry, x plus 4 is equal to y plus 4. Because 4, positive 4, appears on both sides, if I were to cancel it out and isolate for x, I would subtract 4 on both sides, subtract 4 on both sides, that would cancel out, that would cancel out, x is equal to y. We can do the same thing with reactions. So if an entity appears on both sides of a reaction, then we can cancel it out. Sulfate appears on this side and sulfate appears on this side. So now my total net, or sorry, my net ionic would be zinc plus Cu2 plus aqueous forms zinc ions plus copper metal. Okay, and then it does balance out. I have one zinc on this side, one zinc on this side, one copper on this side, one copper on this side. So here is my final answer. There is my net reaction. All right, let's try this one more time. Write a reaction, a totally ionic, and a net ionic equation for the following reaction. Silver nitrate reacts with potassium chloride. Okay, remember this is all happening in solution, so you do need to check if your compounds are aqueous or not. Lovely. So, silver nitrate. Oh, hold on, let me label this. Balanced reaction. I'll do that one first. Okay. Silver nitrate is aqueous plus potassium chloride, which is also aqueous. I'm checking this on page 6 of my data book. It produces, now, what type of reaction is happening here? I have two compounds. Two compounds means that it's a double replacement. I'm going to switch my cations or my positive ions with each other. And I'm going to form silver chloride. When you check the solubility of this guy, it is a solid, forms a precipitate in solution, plus potassium nitrate, and I checked this one, it is aqueous. Last thing we need to do is balance our reaction. This reaction is already balanced. It's all 1, 1, 1. Okay, next step. So we've completed this. We are now going to move on and write a total ionic equation. Okay, first species. Silver nitrate is aqueous, so that turns into silver plus aqueous plus nitrate, aqueous. Potassium chloride, that is aqueous, so that's 1 potassium, aqueous, plus 1 chloride, aqueous. Silver chloride, that is solid, so I leave it as is, and then potassium nitrate turns into ions because it is an aqueous solution. So if you think back to our solutions unit, it would dissociate and separate into ions. Anything that's solid would not dissociate and separate into ions. The last one is our net ionic, and we're going to now look at spectator ions. So for spectator ions, I see nitrate on both sides, so I cancel out nitrate. I see potassium on both sides, so I cancel out potassium. And my net ionic is silver ion plus a chloride ion produces silver chloride. There's 1 silver on each side, and there is 1 chloride on each side. Another way to check if an equation is net ionic is that the charges will also balance out. So on this side, I have a plus charge and plus a negative charge, which gives me a total charge of 0. And on this side, a compound doesn't have a charge, so it also has a charge of 0. So I have 0 on the reactant side and 0 on the product side. That's another way to check that it's balanced. Okay, you try this one on your own. Write the net ionic equation for the following reaction of potassium phosphate with calcium chlorate. I'm going to help you guys write the balanced reaction, and then I'll pause and then have you guys come back and write the equation. So we have potassium phosphate. Looks like this. K3 actually. PO4. And I did check, this guy is aqueous. Plus calcium chlorate, COL3, 2. Okay, I checked on this guy and it is not aqueous. Ask yourself, what type of reaction is happening here? Well, I have 2 compounds reacting with each other, so it is going to be a double replacement. Potassium and calcium are both my metals in this case, so I'm going to switch those 2. I end up with KClO3 aqueous. Yes, this one is aqueous. I checked. And then calcium 3PO4 2, and this guy is solid. Okay, from here we need to balance this reaction. So I'll give you guys a minute to balance it, and then I'll come back with my balancing. Okay, so after I balance this, I get 2 potassium phosphates reacting with 3 calcium chlorates to produce 6 potassium chlorate plus 1 calcium phosphate. Okay, from here, I want you guys to write a net ionic equation. When you are ready, you can unpause and then check your answer. Okay, so first thing you're going to do is write a total ionic equation. So the first compound is aqueous, so I need to write those into ions. 2 times 3 potassiums is going to give me a total of 6 potassium ions on this side, plus 2 phosphates on this side. Okay, the next compound is solid, so I have to leave it as is. Calcium chlorate as is. Okay, on this side, I have 6 times 1 to give me 6 potassiums plus 6 chlorates. And then calcium phosphate is a solid, so I leave it as is. Excellent. From here, you're going to identify your spectator ions. Okay, so I see 6 potassium on this side, 6 potassium on this side. Anything else? That's it. So my net ionic equation is 2 phosphates let's just try writing that all over again. 2 phosphates plus calcium chlorate and I have 2 of them. 6 chlorate plus C calcium phosphate. Okay, so let's just double check. I have 2 phosphates on this side, 2 phosphates on this side. Good. I have 2, sorry, that should be a coefficient of 3 here. I have 3 calcium on this side, 3 calcium on this side. I have 6, 3 times 2, 6 chlorates on this side, 6 chlorates on that side. Perfect. The last thing we can do is check our charges. On this side, I have 6 times -1 for a -6, plus this compound here is 0. So there's a net charge of -6 on the product side. 2 times -3 gives me -6, plus a compound, which is plus 0, which gives me -6. So on this side as well, I am balanced. So my final answer for my net ionic equation is this.